Hello dear students, this is grade 11 mathematics lesson on unit 5 statistics and probability. Today we will focus on measures of location for group data. After revising this lesson, you are expected to compute mean of a group data and compute median of a group data and compute modal values of a group data. So let's continue to the lesson. Let's see first measures of location for group data. The most commonly used measures of central tendency, or measures of location are mean, arithmetic mean, or median, mode, quartiles, deciles, and percentiles. So today we will focus on mean, median, and mode. So let's continue to the lesson. Okay, first let's see mean, mode, and median for ungrouped data. Mean or x bar of a set of data is equal to the sum of the data items divided by the number of items contained in the data. For example, if you have these numbers x1, x2 up to xn in data, to find their arithmetic mean, simply you add the terms and you divide by the total number of the data. So here x1 plus x2 plus up to xn divided by the total number of data is this n, or you can write this using summation notation in this form: the summation of xi's, where I start from 1 up to n, divided by n. Okay, sometimes the data set may be given in a frequency table form like this: x1 having frequency f1, x2 frequency f2, and xn with frequency fn. So in this case the mean is computed using this formula. You multiply the frequency with the data and you sum. So if x1 occurs f1 times, x2 f times, and so on, xn fn times, so the mean is computed in this form. You multiply frequency with the data, f1 times x1 plus f2 times x2 plus up to fn xn, divided by the total number of data. The total number of data is the sum of the frequencies, f1 plus f2 plus up to fn. I can write this using summation notation in this form. It is a summation of fi xi, where I start from 1 up to n, divided by the summation of fi, where I start from 1 up to n. Okay, next, median. Median is the middle value of the set of data when the data set is arranged either in increasing order or decreasing order. When the data is arranged in increasing or decreasing order. So for n number of data, when it's arranged in increasing order or decreasing order, the median is given by this formula. The median will be, it is n plus 1 over 2's item. If n is odd, if we have odd number of data, the median will be, it is n plus 1 over 2's item. For example, if we have 9 data set arranged in order, the median or the middle value is found at 9 plus 1, 10, 10 over 2 is 5. It's found on the fifth value. Okay, if we have even number of data, in this case, the median is given by taking the average of n over 2's item and the next item, n over 2 plus 1's item. So for example, if we have 10 data set, it's even. The median is found at 10 over 2 is 5 on the fifth on 6 value. So you add the fifth and the sixth value and you divide by 2. Okay, now mode. The mode of a set of data is, it is the value in the data which appears most frequently. The data which is found most frequently, we call this mode. Now let's continue. Let's see this example. Here it says calculate mean median mode of the following data set: 5, 8, 8, 10, 11, 11, 11, 16. It's arranged in ascending order. We have how many data? 1, 2, 3, 4, 5, 6, 7, 8 data set here. So first, let's find its mean. The mean is simply computed by adding this and dividing by the total number of data, 8. So when you add this, you get 80. 80 divided by 8 gives you 10. Now let's compute median. Since here we have 8 data set, is even. The number of data is even. In this case, we use this formula. The median is found, its average, or its average of n over 2 item and the next n over 2 plus 1 item divided by 2. Therefore, we have 8 data set here. 8 divided by 2 item plus is the next item divided by 2. So 8 over 2 means 4. The fourth item, 1, 2, 3. The fourth item is here. It is 10, and the next is 11. Therefore, you take the average of the two. It is 10 plus 1 divided by 2. It gives you 10.5. Mode is, it is the most frequent value from this data set. The most frequent value is 11. It appears 3 times. Therefore, the mode is 11. Now let's continue. Let's see the mean, mode, and median for group data. For the group data, the mean is given by this formula. Simply f2 times xc2, it goes on up to fn times xn divided by the total number of data sets or sum of the frequencies. Here, what does this x1, x2, xc1, xc2 mean? Look, for group data, we have classes. Maybe class 1. It may be, let's assume, from 0 to 10, maybe class 1, it's grouped. And for next class, let's assume it is from 10 to 20 and so on. So assume the frequency for this class is this 2, for this class is 4. It's the class midpoint of the given class. For example, xc1 means the class midpoint for the first class. f1 means it is the frequency of the first class. Here, the frequency of the first class is this 2. To find xc, simply you take the average of, or the midpoint of, simply you add upper class limit and lower class limit and divide by 2. 0 plus 10 is this. 10 divided by 2 is 5. The class midpoint for the first class it is 5. Here, the average of these two, 10 plus 20 divided by 2, 30 divided by 15. So the class midpoint for the second class it is 15, its frequency it is 4. After that, simply you multiply the frequencies of each class with its corresponding class midpoint, and then you add. And you divide by, finally, you divide by the total number of frequency. So it gives you the mean. What this means, this one. So here, xci is, it is the class mark of, or the class midpoint of the given class. It's obtained by taking the average of the upper and the lower class limit of the ith class. And fi is the frequency of the ith class. Now let's see about mode. The mode for group data is given by this formula. Mode, the lower class boundary plus d1 over d1 plus d2 times I. So what does this mean? Look. Let's take this data set, group data. We have a class, assume 1 up to 5, 6 up to 10, 11 up to 15, and so on. Okay. Now let's take this one, the frequency here. Assume the frequency on this interval is 3. The frequency here it is, assume to be 7. The frequency here, let's assume 4. To find the mode, we need to find the class boundary. The class boundary is obtained first by determining the correction factor. After determining the correction factor, add on the upper class limit and you subtract from the lower class limit. So for this case, the correction factor obtained by taking the difference of these two and dividing by 2. So 6 minus 5 is this, 1 divided by 2 is this 0.5. So class boundary here, you subtract 0.5 here, it becomes 0.5 up to 5.5. This one from 5.5 up to 10.5. You subtract from the lower limit and you add on the upper limit, upper class limit. So here you have 10.5 up to 15.5. Now to calculate the mode, what you do is first you need to find the modal class from this set, the modal class. The modal class is a class with highest frequency. So the modal class is this one because this frequency is 7. After finding the modal class, you will apply the formula. BL means it is the lower class boundary of the modal class. This is a class boundary. The lower class boundary for the first class is this one, for second class, for third class. So for our modal class, the lower class boundary is this 5.5. So we have 5.5 here. D1 means it is the difference between the frequency of the modal class and the preceding class. So we have 7 here. The frequency in the preceding class is 3. So the difference is this 4. So D1 is it is 4. And to find D2, D2 is simply the difference between the frequency of the modal class and the succeeding class. So it is 7 minus 4. D2 is it is 3. So we have 3. D1 is it is 4. I is it is the difference between upper class boundary and lower class boundary. 5.5 minus 0.5, it gives you 5. So we have found this one. So to calculate the mode for a group data, so we need to find the lower class boundary D1, D2 and I. After that, you can substitute here and you can evaluate the mode. Therefore, here, so BL is this, the lower class boundary of the modal class. D1 is, this D1, it is the difference between the frequency of the modal class and the class preceding it. And D2 is the difference between the frequency of the modal class and the class, next class or the succeeding class. And I is the size of the class interval. And the modal class is obtained is a class with highest frequency, Okay, now let's see about the median. So the median for group data is given by this formula, the lower class boundary of the median class plus total number of data divided by 2 minus cumulative frequency before the median class divided by the frequency of the class times the class interval. This means if we have this group data, let's take the previous example from 1 up to 5 and from 5 up to 10, from 11 up to 15, from maybe next to this 16 up to, assume we have 4 classes, 4 grouped class. Okay, now to apply this formula, we need to find the class boundary. So I need to write the class boundary of this one. So if this was assumed, let's take this one 6. So take the difference between the two. It is 1 divided by 2. It is 0.5. As we done previously, let's find the boundary, the class boundary. The class boundary is from 0.5 up to 5.5. Here from 5.5 up to 10.5. Here from 10.5 up to 15.5. Here from 15.5 up to 20.5. We have this class boundary. Assume the frequency of this class frequency. Let's take to be this one is 3, this 4, this one is 6. Assume this to be 2. So in this case, we need to find this cumulative frequency. So the cumulative frequency here is obtained on the first class. We have 3. First and second class together 7. 7 plus 6, 13. 13 plus 2. 13 plus 2, it is 15. Okay. Now we have this. After this, to apply this first, we need to find the median class first. The median class. The median class is obtained by taking or by dividing n by 2 and taking the least cumulative frequency, which is greater than this one. Here we have the total data set is 15. When you divide 15 by 2, it is 7.5. So the least frequency, cumulative frequency from this set, which is greater than 7.5, it is a least number from the cumulative frequency is the least one, which is greater than 7.5. Therefore, this part will be the median class. After determining the median class, you can apply this formula. So the lower class boundary of the median class, it is 10.5. n is it is 15, 15 over 2, minus this one is it is the cumulative frequency before the median class. Here is the median class. The cumulative frequency before this class is this one. It's not the frequency, it's a cumulative frequency. The cumulative frequency before the median class, we have 7. We put that number here. And this means it is the frequency of the median class itself. The frequency, it's not a cumulative. The frequency of the median class is this 6. You put this number. And I mean simply taking the difference between upper and lower class boundary. So after that, you can apply this formula to calculate the median. So here BL is this, the lower class boundary of the median class. And CFB is this cumulative frequency before the median class. FC is the frequency of the median class itself. And I is the size of the class interval. And the median class is the lowest class for which the cumulative frequency equals or exceed this n over 2. The lowest class with cumulative frequency exceeding this one or equal to this one, n over 2, is this the median class. Now let's see example for this data set. This data set is given on first class from 0 to 5 is 5, 6 to 11, 8, and so on. So we need to find median, mean, and mode for this data set. To find these values, first I need to convert this into class boundary, from 0 to 5, 6 to 11. So to form class boundary, take their difference and divide by 2, it is 0.5. Add 0.5 on the upper, subtract 0.5 from the lower part, you'll have this one. And then put the frequencies here, 5, 8, 7, 5, 8, 7, 10, 3. And we need to find also cumulative frequency. Cumulative frequency, 5, 5 plus 8, 13, 13 plus 7, 20, 20 plus 10, 30, 30 plus 3, 33. And since we need to calculate the mean, we need to find XC. XC is the class midpoint of each class. The class midpoint is obtained by adding lower class limit and upper class limit and dividing by 2. 0 plus 5 over 2, it is 2.5. Similarly, for second class, the class midpoint will be 6 plus 11 divided by 2, it is 8.5. And you do for the rest in similar way, and you'll have 14.5, 20.5, and 26.5. After this, since we need to calculate the mean, so to calculate the mean, we need to find this one, the product of the frequency of each class with this corresponding class midpoint. So first, for the first class, the frequency is 5 and its corresponding class midpoint is 2.5. The product of the two, you get 12.5. For second class, 8 times 8.5, 68. For third class, 7 times 14.5, 101.5, and so on. Do the same for the rest. And when you add this, you get 466.5. Please check the numerical value of this at the end of the lecture. Now, to calculate the mean, simply you take the summation of the product of the frequency and the class midpoint of each class added, and you divide by the total number of frequency. Since we have the sum is this 466.5 and the sum of the frequency is 33. Therefore, here you will have 466.5 divided by 33, you get 14.14. So the mean will be this 14.14. Okay, to calculate the median, first we need to find the median class. We have 33 data. So divide 33 by 2. 33 divided by 2, it is 16.5. So we search for a class with cumulative frequency greater or equal to this one. The least frequency, cumulative frequency greater or equal to 16.5. Here it is 5, here it is 13. It does not exceed 16.5. Here it exceeds 16.5 and it's the least cumulative frequency. It's lesser than the other. So the median class is this one. It is a median class. Therefore, from the median class, its lower class boundary is this 11.5. So here BL is this 11.5. Total number of data set is 33. 33 divided by 2 minus the cumulative frequency before the median class. The cumulative frequency before this median class is this one. The cumulative frequency before this class 13. So 13 divided by the frequency of the class. The frequency of the class is the frequency is 7. The frequency of the class. Therefore, you have 7 times I is this the class width. The class width. Simply take the difference between these two. 5.5 minus negative 0.5 gives you 6. So you have 6 here. Therefore, when you evaluate this one, you get 14.5. Therefore, the median will be this 14.5. So to calculate the mode, we need to find the modal class. So the modal class is a class with highest frequency. So here, from this set of frequency, the highest one is this 10. Therefore, this one is the modal class. This is the modal class. So its lower class boundary is 17.5. So here BL it is 17.5. D1 means it is the difference between the frequency of the modal class and the preceding class. Therefore, D1, to find D1, the modal class is this one, it is 10. Its frequency is 10. The preceding class, it is 7. So 10 minus 7, it is 3. D1 is 3. And D2 is simply the difference between 10 and 3, succeeding class. D2 is this 7. D1 is 3. And D1 is 3 and D2 is 7. So 3 over 3 plus D2 is 7. I is this similar to the above one, it is 6. So when you evaluate this one, you get 19.3. So this is it. To summarize what we have seen today, the mean for the group data is given by this formula f1x1 xc1 plus f2 xc2 plus fn xcn divided by f1 plus f2 plus up to fn. And the mode for group data is given by mode is equal to the lower class boundary of the modal class plus it is the difference between the frequency of the modal class and the preceding class divided by D1 plus D2 times I. And the median for the group data is given by median is equal to this, the lower class boundary of the median class plus n over 2 minus the cumulative frequency before the median class divided by the frequency of the class times class size. So this is it. This is all about today's lesson. Please do exercise 5.3 on page 159, exercise 5.5 on page 163, and exercise 5.7 on page 167. This is all about today's lesson. Until next lecture class, goodbye.